All right, so today we're going to talk about graphing quadratics, and we're going to do so in vertex form. So last time we talked about graphing quadratics, it was in standard form, and we had to use opposite b over 2a to find the axis of symmetry and the vertex and all those kinds of things. The nice thing about vertex form you're going to find is that it eliminates any need to do opposite b over 2a. You're also going to start feeling a lot of deja vu, because a lot of what we do with quadratics, parabolas, and vertex form mirrors what we do in absolute value. So we'll keep making those ties back and forth from there. Okay? All right, so the point today is to make sure that we can identify and graph quadratic equations in vertex form. We've already done standard form, so now it's got to be in vertex form. Okay? Now, in class we were able to do this Desmos activity that kind of showed you how a parabola moved with numbers filled in different places. Okay? Basically what we found out in that activity was exactly what we saw with standard form with our A. A is going to tell us our end behavior. If it's positive, then the graph's going to open up. If it's negative, it's going to open down. If A is bigger than 1, then the graph is going to narrow. And if it's a fraction or a decimal, then it's going to start to widen out. Or even more to the point, if it's a smaller A than another graph, it'll widen out some. Okay? Now, the part where we start to get into be a lot like absolute value is things like this, the H, right? So vertex form has us looking at A times the absolute value of x minus h squared plus k. So inside the parentheses, we're going to have a minus h. Or, in other words, we're going to have an h value. And what we saw through Desmos is exactly what we saw with absolute value. When h is positive, that actually shifts our parabola to the left. So it still gives us that horizontal shift left and right, h for horizontal, right? If h is positive, it's going to move to the left. If h is negative, it's going to move the parabola to the right. The k, which is going to sit right outside the parentheses, is going to move our graph up and down. It's going to shift it up and down, like a kangaroo, k for kangaroo. Right? So if k is positive, it's going to shift our parabola up. And if k is negative, it's going to shift our parabola down. Now, we're talking about shifting. And what I'm talking about is shifting the parent function. We'll take a look at the parent function in just a second. All right? So, let's start talking about how things are going to be different from this parent function. The parent function is y equals x squared. And so the question is, this new guy, how is it going to be different than the parent function shown here, y equals x squared? Well, we're taking a look at this, and what you see first is that a is negative, so this parabola is going to open down, where the parent function is going to open up because its a is positive. And since 2 is bigger than 1, right, because the parent function a is 1, since 2 is bigger than 1, that means this graph is going to be a little bit thinner than the parent function. Now, the parent function has a vertex, and it's at 0, 0. We'll look at that in just a second. But how is that vertex going to shift for this graph? Well, we see that h is positive, so that means that we're going to shift the vertex left 3. K is negative, so we're going to shift the vertex down 5. All right? That's how we want to use A, H, and K to kind of get some idea of what that graph is going to look like. Okay? Next guy, how is this guy going to be different than the parent function? And remember, we're just talking about how is it going to be different. Well, both the parent function and this guy are going to open up, and they're going to be the same width because the a's are the same. They're both positive 1. Now, in our new guy, h is here, and it's negative 3. So negative 3 means that we're going to shift to the right, and we're going to shift to the right 3 spaces. There's not a k out here, which means that k must be 0, and therefore it's not going to move our graph up and down at all. So the only difference is that our new graph is going to be shifted to the right. We're going to take the parent function and shift it to the right 3 spots. Okay? All right. Now, try 3. Take a look at 3 and see how it's going to be different than the parent function. Take a second, write these out. You can stop the video and then start it back up and see if you're right. Okay, so how'd you do? Because a is negative, then our new graph is going to open down. And because a is 1/8 versus 1 on the parent function, our new graph is going to be wider. Now, were you careful? H is -9, and A always shifts opposite of what we think. So since H is -9, that means we're going to be shifting right 9. And if K is -11, that means we're going to shift down 11. Okay? H is opposite, K is the same. All right? Good. Now, let's start talking about using this shifting and this stuff and talk about how to graph in vertex form. Well, in order to understand where the graph's going to move as we talk about these shifts, we need to understand where the parent function is. So the first thing I'm going to do is graph the parent function for you. And I'm going to use it, and I'm going to do it in blue up here at the top. This is going to be separate from our actual problem here. It's y equals -x plus 1 squared plus 8, okay? To graph the parent function, I'll use all the stuff that we did in the last class because we haven't figured out how else to graph just yet. So that requires an axis of symmetry, which is going to be that x equals opposite b over 2a, right? Well, what's b? In the parent function, we do not have an x term, so that means the coefficient on that missing x term must be 0. So b is 0. And a is 1. So we go 2 times 1. Well, 0 divided by 2 is just 0. So the axis of symmetry for our parent function is going to be x equals 0. And that's just the vertical line going down the y-axis. Okay? All right. Well, for the parent function, we know the vertex has to sit on the axis of symmetry. So the x-coordinate for the vertex is going to be 0. To find the y-coordinate, we just plug that 0 in for x. So right here, well, 0 squared is 0. So the vertex for the parent function is at 0, 0. Okay? Now, I need some more points. So I can create a table of values like we did in the last class, right? Just pick a bunch of x's, plug them into the function, and find out what the y is that goes with them. All right, we talked about making sure we choose 2 x's that are on the same side of the axis of symmetry and making sure that they're as close to the vertex as possible. So I'm going to choose 1 and 2. That's going to be easy enough to plug into the function. If we plug in 1 to the parent function over here, 1 squared is just 1. If we plug in 2, 2 squared is 4. As a matter of fact, we can keep, this is easy enough. We can do another point if you want to. How about you plug in 3 for x? Well, 3 squared is 9. So we're looking at points 1, 1, 2, 4, and 3, 9. And then we can mirror image these points. And this is your parent function.
David Wapo, please call extension 4400. David Wapo, extension 4400, please.
Sorry about that. All right. Anyway, that's your parent function. It's not the graph that we're actually trying to do. Okay? This guy over here. As a matter of fact, for right now, we need to get used to putting the parent function in the grid every time. This is going to be the parent function every time. Your points are going to be 0, 0 for the vertex, 1, 1, 2, 4, and 3, 9. All right? Now, to kind of get an idea of where our new graph is going to be, and I'll change colors here for you, we need to start looking at how our new graph is going to be different. Right? We know that our new graph is going to open down. It should be just as wide because the actual A values are a little bit different. Okay? Now, we're going to shift the parent function vertex, which is always at 0, 0. Always. The parent function vertex is always at 0, 0. But we're talking about shifting the whole graph now. And if h is positive 1, that means we're going to shift the whole graph to the left 1, not to the right. Remember, we do the opposite, to the left. And if k is 8, that means we're going to shift the whole graph up 8. That means that the vertex is going to shift over 1 and up 8. And so it's going to end up right here.
David Watt.
Okay, sorry about that again. Well, that means that our vertex is going to be at negative 1, comma 8. And we didn't even have to do any opposite b over 2a. Right? And that's just because we shifted the whole parent function. We shifted the vertex. You're going to start to see a pattern where the new vertex, when we're in vertex form, the vertex of the graph. All right, sorry again. What you're going to find is that the vertex in our graph is just going to be opposite h, same k. Just like it was for absolute value. It was the same way in absolute value. Opposite h, same k. So now our vertex is at negative 1, comma 8. I'm going to take these arrows out so we can graph and not get too crazy. Okay? Now, that also means that our axis of symmetry is going to be that equation. Remember, the vertex has to go through the axis of symmetry. So the axis of symmetry has to go down here through the vertex. And if I were to write the equation of that vertical line, it would just be x equals negative 1. Okay? Now, our new points. Our new points. And all right, so now we want to create our new points, or our additional points to help us come up with the shape of the graph. Well, again, A will help us with that. A is going to tell us that we're going to actually open down now, and it's going to be just as wide. Now, the way to make that happen is we're going to use the same table of x and y values that we did for the parent function. 1, 2, 3, 1, 4, 9. Excuse me. But now, instead of looking at these as points, I'm going to look at this as how I walk from the vertex, right? Here's what I mean. This tells me that if I walk one space over from the vertex, I need to walk up one space to get to the next point. If you go over to the vertex of the parent function, you're going to see that. You're going to see that if we walk over one space to the right, we have to go up 1 to get to that new point. The next line tells us that if we walk over to the right 2 spaces, we have to go up 4 to get to the next point. And you see that again. If you come over here, you walk 2 spaces to the right, you have to walk up 4 to get to the next point. And the last line says that if you walk over 3, you have to go up 9. And you see that again. Go back to the vertex. If you go over 3, then you have to go up 9 to get to the next point. Now, our new graph is going to be the same way, only we know that it's going to open down. A is going to change how we walk in our new graph. So instead of doing this, I got to take the A in our new graph, which is negative 1, and multiply all of these y's by negative 1. And that will tell me how I'm supposed to move now for my new graph. So now, instead of going up 1, up 4, up 9, I'm going to go down 1, down 4, down 9. So I'm still going to walk over from the vertex. So if I walk over 1, I'm going to go down 1 to get to the next point. If I go over 2, I'm going to go down 4 to get to the next point. And if I go over 3, I'm going to go down 9 to get to the last point. And that will give us a good idea of the shape of our graph. Now, it doesn't matter which way you walk over, whether you go right or left. Walking down 1, then down 4, then down 9 is the same. And then we can graph our new graph. Okay? That's our process, and we'll speed this up a little bit in the next example. But that's how we're going to graph. Okay? Now, we're going to talk about domain and range really quick. We did that last section too. Domain, again, you should never miss this. It's always going to be negative infinity to positive infinity. While that graph is opening down, it's also going out, so it's going to cover the entire x-axis. The range, since it opens down, it is going to cover all the way down to negative infinity. So we start our range there. And it's going to stop covering the y-axis at 8. That's where our vertex is. So it's negative infinity to 8. Okay? Does that make sense? All right, let's take a look at the next. All right, y equals 1/2 x squared minus 5. Now, again, we need to put the parent function down here, the vertex at 0, 0, and then the points 1, 1, 2, 4, 3, 9. It's basically just squaring whatever x you would plug in, right? So there's our parent function, and now we're going to graph this new function, right? We're going to shift. First of all, we're going to shift. And the vertex for the parent function, again, is at 0, 0. And we saw the last time that h and k will shift it, and basically that means that your new vertex is going to be however h and k would shift. Well, h always goes opposite the way we think, so we need opposite h, and k always goes the way we think it should. So we're going to use same k. Opposite h. Well, if you look, there's not a set of parentheses. So there's not a number inside of parentheses. That means h is going to be 0. Now, there is a k. There's a negative 5 that's sitting outside the parentheses. I'm going to take same k. So negative 5. So I'm going to shift the vertex down 5. So I'm going to shift down 5. That puts me at 0, negative 5. That's right here. Okay? Now, as we saw last time, the parent function has you walk over 1, up 1, over 2, up 4, over 3, up 9 to get to each of the points. Well, our a, which is 1/2, is going to change the way you walk. So we're going to multiply all the y's by 1/2. So we get 1/2, 2, and 4.5, or 9 over 2, but I think 4.5 works well. Excuse me. So those are our new walking points, right? So I just need these guys right here. That means that from the vertex, if I walk over 1, I got to go up 1/2. So my new point is going to be here. If I go back to the vertex, if I walk over 2, I have to go up 2. Go back to the vertex. If I walk over 3, I have to go up 4.5. So go up 1, 2, 3, 4.5. And we're right there. You can mirror image those points and then draw in your parabola. Okay? Now we did forget the axis of symmetry. Remember, the axis of symmetry is always that equation, x equals the x coordinate for the vertex, because the vertex has to sit on that axis of symmetry. Okay? So there we go. Let's do domain and range really quick. Domain is, you better get it right, negative infinity to positive infinity. And then the range, our new graph, the red graph, opens up to positive infinity. So our range is definitely going to go to positive infinity, which is we're going to put on the right. And it starts covering the y-axis at negative 5. We want to put a bracket around negative 5. Okay? And then we're done. All right, let's try this guy. And I thought about maybe a different approach here. Let's try something here. We know we're going to graph the parent function. So we need to get in the habit right now. The parent function, the vertex, is a 0, 0. And its table of values for points are 1, 2, 3, 1, 4, 9. Let's write that down every time. Excuse me. Let's write that down every time, and then we can use that to graph. 0, 0, and then 1, 1, 2, 4, 3, 9. We're going to do this every time. Now, our new graph. Our vertex is going to change, and our table values are going to change. So how are we shifting the parent function? Right? Remember, h is -6. We want to shift opposite the way we think that it's going to shift. So we're going to shift the vertex from the parent function to the right 6. To the right 6 means that my x-coordinate is going to be 0 plus 6, which is 6, right? The k is -1. That means we're going to shift the vertex of the parent function down 1. Well, down 1 means that we're going to change our y-coordinate to -1. So there's the new vertex. Let's go plot that. 6, -1. Now, I need, well, first of all, the axis of symmetry. Let's go ahead and write that in. Remember, it's always x equals, it's an equation. X equals the x-coordinate of the vertex, which is 6, because the vertex is going to sit on the axis of symmetry. Now, I need a table of values for my new graph as well. I'm still going to use 1, 2, 3, but I'm going to multiply the parent function table of values by my a. And so I get 3, 12, 27. So what that tells me is if I walk one step over from the vertex, from the new vertex, I have to go up 3. If I walk 2 steps over, I got to go up 12. So one step over, go up 1, 2, 3. 2 steps over from the vertex, go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Excuse me. 12 puts you here. And we can walk 3 steps over, then we have to jump up 27. That's kind of crazy, so we're not going to worry about plotting those last points. But there we go. Now we're done with our new graph. It's just that easy. Hopefully you're finding this easier than the standard form, right? Where you have to do opposite b over 2a and all that stuff. So, how about domain and range? Your domain better be negative infinity to positive infinity. It's what it is every time. And then your range. What y values are we going to cover? Well, we start covering at -1, and it opens up to positive infinity. So that's going to be your range. Okay? All right. You got one more. Hopefully that makes enough sense. Go ahead and try one more. You can stop the video, start it back up, and check your answer. Okay? Did you get that? All right, so the parent function, again, the vertex is at 0, 0. The table of values are 1, 2, 3, 1, 4, 9. And you see the blue graph there is the parent function. Now, the new vertex, we have to shift the parent vertex to the right 2 because h is -2. We go opposite h. So our new vertex is at 2, 0. That means the axis of symmetry is the x equals 2. And then when we create our new table of values, we have to multiply the y column from the parent function by 1. It doesn't really change anything. So we're still going to go 1, 2, 3, 1, 4, 9. So we go plot the vertex for the new graph at 2, 0. Then we're going to go over 1, up 1, over 2, up 4, over 3, up 9. Always going back to the vertex to start our walking. Okay? So there's our graph. The domain, negative infinity to positive infinity. The range, right? It opens up to positive infinity. So we can put that in first, which has to go on the right. And then it starts covering y values at 0. So it's 0, infinity. Okay? Hopefully that makes enough sense. Homework's out in Canvas. Give it a shot, and we'll see how you're doing next time.